So, hi everyone. I'm a Gen AI developer advocate from DivBot, and today I'll be talking about how knowledge graphs can help you build more trustworthy and explainable LLM-based applications. So, just to make it clear that everyone can see my screen being shared, right? Okay, sorry, I can't see the message. Okay, thank you. So, well, right now, ChatGPT has come out for like 2 years ish, and we all know they're great, they're powerful. But sometimes, till now, we're still experiencing hallucinations. Rather, it's like from Anthropic's Claude AI or ChatGPT, we still have that. And if it's just like a for fun activity, it's fine, right? Like we don't care. We can have fun and just like troll a little bit about LLMs. But for enterprise applications or for like some of the applications that we really need to know, like where do we get this output and how does LLM retrieve those? We need more transparency regarding that and how do we do that. So there's in this session we'll be talking about how knowledge graphs can actually help that. So, well, because we're at nodes, Neo4j's nodes 24, you guys probably have attended a lot of sessions talking about knowledge graphs. I assume most of you are familiar with knowledge graph, but I still want to give you like a TLDR of knowledge graphs. First, I'll jump into this slide. It's like the TLDR of knowledge graphs is interconnected structured data. And in brief, it's like right now where you're seeing here, actually, this is a graph that I borrowed from Google. Like they introduced this knowledge graph term in 2012. And basically, it just means that the entities that you're seeing here, such as Da Vinci, Mona Lisa, or the locations such as Paris or France, we can link them with relationships. So these, like all these facts that you're seeing here, can actually be connected into a map, right? Now that all facts are connected, and we have a map of facts. So what we will need is like if we provide this map of facts to LLMs, it could actually help LLMs better retrieve information because they can traverse. Like if I ask about like where Mona Lisa is in, and LLMs can refer to this map and say, oh, Mona Lisa is in the museum, the Louvre museum, and the museum is located in Paris. So I know that Mona Lisa is in France or in Paris because it has this relationship to traverse from. Okay, so this is the concept that I hope everyone is on the same page on. And then we'll go back to like what's gonna happen in this session. So first, later I'm gonna show like why knowledge graphs can be helpful for LLM-based systems. And actually, I'm going to show very briefly it's a joint effort by DivBot and Neo4j. It's a mini graph rack, but you will see like how this can do. Why does it have to do with explainability or trustworthy information? And then the second is how to build a graph rack. Well, a lot of you probably already know Neo4j has this LLM knowledge graph builder, and I'll show you if you want to use DivBot to build a knowledge graph, how you can do so. And then the third one is like, should we aim for vector rack or graph rack, or actually we don't even need that question? Okay, so as I mentioned, well, so first, sorry, I didn't explain too well. DivBot is we build the world's largest knowledge graph. To be fair, we organize the web data like you can think of like the information you see on Google. We organize those internet web data into a very large knowledge graph. So if you want to like grab any like web internet information, you can simply just enter any. I actually have a notebook here to share. Like if I want to know about Google, right? And and I want to know, okay, the summary, and it will shows, oh, like what is this about, and the category is like what industry it is in, and we have lots of data that, sorry, it's a little bit messy here, but later I'm gonna show you this the more clear version of this application. So okay, actually this is the one I'm gonna show you. Okay, so this is the application that I mentioned previously, like Neo4j and Diffbot. We jointly create a graph rag application, and we mainly build this graph rag with Diffbot's API. As you can, I'll just show you actually. Like, this is a little bit complicated here, but we would, so for example, if I import articles such as, like I said, NVIDIA, and I already have the data in the backend, so I'm not gonna submit again. But what this is gonna do is actually gonna import articles, recent articles related to NVIDIA. And if I click submit, it will actually just create like notes and data from related to NVIDIA. So we can see, like, initially it's the database is empty, but if I click on this, what you're seeing here is the description, the employee count, the founding date. Like, these information are all from just imported from Diffbot, because we have all the information. Yeah. Okay, and then it will also like analyze the sentiments, or how many entities there in the articles too. So eventually, this is actually a very mini representation of what the graph actually is. What, like a small knowledge graph. If you wanted to have a clearer view, you can see it in the back end. And later on, I can provide, this is actually from a GitHub repo we already have, that you can just use this application, import articles related to this company, and further enhance information from this company into the Neo4j database. And then finally you can chat about it. Like, so the more clear example is, like, if I want to say, like, who are NVIDIA's suppliers. Let's do this. Okay. Okay, so this is a live demo that you can see. It start to list out. Well, this is a very, very long list to for sure. But who are NVIDIA suppliers? Like, right now, what you're seeing here is actually being retrieved from structured data from knowledge graph, because we already. Yeah, I'm sorry.
Leann, sorry, just to interrupt. I think you're screen sharing the wrong screen. Just wanted to inform you.
Oh, I'm sorry. I'm so sorry.
No worries. Thank you.
Okay, so you guys, okay, so probably you guys seen this or not? I'm so sorry. And let me can I share another tab that I have, because I've been switching around the tabs a little bit.
You should be able to, in the screen share, pick whether you share a window or a tab when you share your screen.
Okay. Oh, I see. Okay, so I'm so sorry. Oh, okay, guys, I'm so sorry. Okay, so you guys probably didn't see this. I'll repeat it again. Sorry. Thank you for your patience. So this is actually the graph, the mini graph rack we built. It's a joint effort by Diffbot and Neo4j, where we import like web information. It's a structured data into Neo4j. So there are multiple steps, and previously I was like, if there's like, you can enter the company name and import relevant articles. And there's a lot of stuff that do a lot of like entity and relationship extractions from the articles, and further enhance it. Okay, so all that details like aside, the most important thing is you will get Did you see a Neo4j graph database here? Yes, right? Okay, cool. So wait a second. Okay, so here, this you see like a huge, larger web of information from a large web of like information. Yeah, exactly. They're being structured, and if I go find, NVIDIA or all these other companies, you can see that they have different relations being connected, such as like who like Goldman Sachs. They're competitors with HSBC, and there other articles that mention these organizations as well. Okay, so let me show like what this backend graph database is actually powering in the front end. Okay, so I guess we're back to the mini graph rack application, mini graph applications. And if I ask like, who are NVIDIA's, let's say, suppliers? Okay, so if I hit enter, you see like this is a live stream, like it's live, and and it's a really, really long list. Okay, so right now, like we want to know why we are getting this information, right? Like are LMs hallucinated, or how can I trust like this information is correct? So here's another tab that shows the context that this graph like the like what data LMs is retrieved, and you can see here it listed all the structured information such as NVIDIA's partnership, and like which industry is in, has CEO, of course, Jensen Huang, a lot of subsidiary, board member, found, and then here competitor and suppliers. So the output that we are seeing is extracted from here, you know. And you see that this is structure, and of course, like if we want to have this information, we of course we have to have quality knowledge graph built in the first in the beginning, and I'll talk about that later. But here you can see, structured information from knowledge graphs being retrieved, and there's also like additional unstructured data, which are the articles we've previously imported related to NVIDIA. Is also imported. So this way, LMs can reference both structured and unstructured data to form output. It's instead of just relying entirely on vector-based data. So this is what this mini graph rack, it's actually a vector plus knowledge graph application can do for you, and you can like know more clearly like what LMs is retrieving the information from. Okay, so let's go back to our slides, and and I'm showing this slide again. I know you guys have like being confused like why she's sharing this slide for a long time, but it's also promoting Neo4j has this like knowledge graph builder, and you can use like other like LLMs such as OpenAI, Gemini, or you can use DevBot. And actually, right now we have been offering like free tiers. You can sign up and get tokens really quick. Okay, so we talk about knowledge graph and how knowledge graphs can enhance LLMs applications, but how to build quality knowledge graphs, right? Like for example, if I would actually later ask like if anyone can submit a random paragraph, and we can do like a fun activity, extract entities and relationships. And how can we ensure that if we submit, like if we present a random paragraph, and all entities and relationships can be extracted correctly? So and right now, like probably a lot of us turn to LLMs, which are great. Like they can understand entities, like which entities are organizations, and the relationships between entities, fine, pretty well. But Like, so this is a previous experiment I've done with GPT-4 a while ago. But to be fair, right now, they're like LMs and new models are coming out every now and like every few weeks, every few months, and they're getting better. This is undeniable. But what we still have to keep in mind is like the accuracy of like how precise and how correct the output can be. Like this is we still need a lot of evaluations on that, but LMs they still have this hallucination problem. Probably that will be solved in future. We don't know yet, but you can see there's some errors in the output. And there's also another thing called entity linker, which I don't think I have time to share. But here is another output I want to share is like this is also the related to the previous side I share. Like I I give GPT-4 a paragraph regarding like back then, like when Sam Altman got fired from OpenAI, and that news articles, I asked GPT-4 to extract entities, and you can see just a few paragraphs aside, Sam Altman, like at one time it's like identified as a person, but just a few lines after it's categorized as an organization. And the same happened to Greg Brockman too. So, and this problem happens like it's not only just a hallucination problem, it's also related to right now LMs have this like context window limit, right? A limitation because they can memorize like the information you present before if it's outside the limitation, context window limit. So there's still something that we have to keep in mind, and definitely human in the loop to evaluate like if the entities and relationships are being extracted correct are very important. But like and because like a good knowledge graph is the foundation of how good, how accurate your graph based your knowledge graph based LLM applications will be. So any alternatives, of course, and that's why I'm here, is that, well, previously we already talked about like at the Neo4j knowledge graph builder, you can select FBot, and we now have a free tier. You can get your free token. Okay, so actually here I want to ask anyone, like, can anyone share a random paragraph of text to me, and we will do a live entity and relationship extraction text. Sorry, I didn't catch up the session chat fast enough. Okay. Is anyone able to share any paragraph? Like it will be fun, or I can skip it. It's okay too. Chat message. Okay, so oh, nice. Okay, so there's a font. Thank you for sharing. Let me copy your paragraph. And wait. Oh, okay. Sorry, I copied the wrong. I'll copy a tiers. Give me 1 second. Okay, and let's go back to. Okay, so this is a random paragraph. Sorry, I think I randomly copy everyone's. Okay, so this is a paragraph from a tier, if I pronounce it correctly, and we'll see how this goes. Okay, so you can see right now it just it extracts like Berkeley and city and all these other like related information, and there's a graph being created here. And what's like further like the related to the transparent or the factual accuracy is like if we go to entities, you can see that these cities, they are being categorized into different types, and it will also give you like, okay, wait a second. there's the salience. Yeah, salience is like how recent this information is being updated, and the other, yeah, types. And yeah, so on the entities tab we can't really see the relationship, but in the graph you definitely can see. And right now, what I mean, previously the diffbot application, if you still remember this one, like what you have seen, like the partnership data, the competitors relationships, they are already in, you can get it from diffbot, and it's like defined already. Okay, so that's just like a fun example of, like, a random paragraph, and you can get the entities and relationships extracted very quickly. And also, like, you can ensure, okay, like how trustable, how trustworthy this is. Because if I click on UC Berkeley, okay, or yeah, super Berkeley, yeah, I have to. Okay, so if I go to, yeah, I see, this is actually a step related to knowledge graphs. The entity linking is like, it's identified as a legit name, and it will connect to all of the information related to this. And this is a knowledge graph thing that it could further verify how factual your information is by linking it to the original knowledge graph. Okay.
Sorry to interrupt. I think we're looking at just want to check we're looking at the correct screen.
Yeah. So
Perfect.
yeah. Okay. So I'll go back to my my screen. Okay. So, and the last thing is, like, so do we go for vector or graph based, right? Because or like people sometimes are debating whether vector or graph based. And as I demoed previously, you already probably get the feel of, like, why not both, right? And Neo4j, like it's a, like, fortunately Neo4j, it does support both like vector search and graph based. As you can see, if I go to share this, and now I'm back to the Neo4j graph database. You can see if I click on an article, I think there's an article that you can actually see. I think it's this one. Okay, so probably not. Yeah, right now I can't see that, but like from other sessions or like research from Neo4j, you can see the chunks, or from the articles, like they have embeddings as properties under the chunk node or the article. And so, like, when we are like on this, like, mini graph rank application, that the structured data, the unstructured data that we're seeing here is actually being searched in the backend using vector search, vector similarity search. So this is pretty cool that you got cipher query querying the structured information, and also the unstructured information from vector similarity search. And that's what Neo4j can help you do that. Okay, so this is pretty much my presentation. I'm sorry, like, sorry. This is okay. So if currently I make videos regarding like knowledge graphs or LLM-based applications on YouTube. I make YouTube videos on diffbot. Or if you have some questions, you feel like, Leann, I'm still confused by your presentation, and you can reach out to me, and I will say sorry, and I'll say thank you for your patience, and we can also further talk more about that. So this is my presentation. I appreciate everyone's patience, and I hope you learned something new today. Thank you.